In this video, I'm going to be building a desktop computer to be my home network drive. This is essentially going to be a local server that's going to allow anyone on my home Wi-Fi network to share files or access files that I want to make available to guests. Any user that I set up with an account will have their own personal folder on this server that only they can see, which they can use for extra storage or for transferring personal files between computers. So let's get started. I just assembled this computer, and the first thing I'm going to do is install the latest version of Ubuntu. There are several flavors of Linux, and I'm choosing Ubuntu for this system because it's known for having a lot of commonly used packages already set up and configured, making it easy to use out of the box. So I download the ISO image from the Ubuntu website and used a Windows-based program called UNetBootin to create a bootable flash drive, which I will use to load the operating system. Next, I'm going to be running the Linux installer from where I can format the primary hard drive in the ext4 file system, and then install Ubuntu. At the prompt to name this server, I'm going to call it Ciao Stella, which is named after a special restaurant in New York City. But you could name your server anything that you'd like. So once the server is set up, I can access it from another computer on my home network. In this case, we'll be using my Windows 10 machine running the Windows subsystem for Linux, which for practical purposes means I'll be remotely logging in from another Linux system running Debian. We can ping our newly established server by its Ciao Stella name on the network. The local Wi-Fi router is handling the DNS lookup, which is what allows us to find it by that name. So next, I'm going to run the SSH command to start a new remote session. For the storage of user data, I'm going to be using a secondary hard drive with 5 terabytes of space, and I want to format this drive in the ext4 file system, which is native to Linux. We can see how Linux identifies the drive as a piece of hardware by using the lshw utility, passing the "-c disk option to filter the results. I find it easy to remember the name of this command by thinking of lshw as being similar to the ls command, but instead of files, it lists available hardware. So as you can see from this screen, the crucial disk is the primary one that I've made for booting and running the operating system, and this drive named Elements is the one that I want to use as my network disk. Note that Linux is identifying this drive as dev SDB. Now, let's check how this piece of hardware is currently partitioned into local drives. Linux provides 2 utilities that you could use to look at this information and repartition: fdisk and parted. According to the Ubuntu documentation, fdisk is an older utility and has some limitations. It can only create master boot record type of partitions, which isn't the best kind suited for secondary storage drives, and it has a size limitation of 2 terabytes. So for this 5 terabyte hard drive, it makes sense to use parted. We can do sudo parted dev/sdb and then print to see the current partitioning status of that drive. As you can see, it has only one partition that is currently formatted in the Microsoft NT file system. We want to change this to the native Linux type of file system to ext4. So first, let's remove that existing partition, and then we'll create a fresh one. Keep in mind that this is a dangerous operation because if you have data on that drive, it's going to wipe it out. Okay, let's make this easy by setting the units in parted to specify that we'll be working with terabytes as well. So now we'll use the mkpart command to set the partition name and file system type to ext4, starting at position 0 and ending at the end of the drive, 5 terabytes. Now you can see that partition 1 is set up to have an ext4 file system, and it's named Ciao Stella Share, and no longer has the Microsoft data flag. Now we've got to actually format that partition, which we'll do using the utility mkfs. Note that when I'm typing this command, I'm pointing it to dev/sdb1 to point to that first partition that we created. Next, I'm going to mount the drive so that we can access it through regular file system commands. We're going to do that by creating a file system directory that will point to this drive. and I'm going to call it /media/ the name of the drive, which is Chow Stella Share. And then we're going to set up the mount of that file system directory to the drive contents by modifying the Linux fstab file under etc/fstab, which specifies all the mounts to be automatically loaded when the system boots up. This is a tab delimited file, and each column represents some settings related to the mounting of that particular file system. Now, instead of rebooting, the reload of the fstab specified mounts can also be triggered by running the command sudo mount-a, and now we can do ls on that directory, and you can see here the lost and found system folder. So the way I want to organize this drive is to set up a subdirectory named NAS for what will be the network attached storage related stuff. That'll give me the flexibility I need to make other folders later on for other purposes. And now we're ready to begin setting up the file sharing server software. The server message block protocol is a commonly used networking protocol for communicating with network drives, and a Linux implementation of that on the server side is a program named Samba. We can install Samba on our Ubuntu 2004 system by the command sudo apt install Samba. Once we've got that installed, we can configure it by modifying its smb.conf file to tell it how we're going to manage file sharing. So at the bottom part of this file, you can set up several sections specifying the shares that you want to make available. What you see me initially typing here isn't what I ultimately settled on. It took me a few tries to get this exactly how I wanted it to run, and here's a screenshot of the finalized settings that I came up with. First, let's talk about the home section, which carries a special meaning in this program. I'd like to set this up so that there are several independent users who can access its network drive, but have their own private space. User A should be able to have a folder that only user A can access, and won't be able to change the content of a folder for user B. And this is where the Homes feature comes in. When configured, it will allow each user the ability to manage their own independent folder of files. So in the arrangement I have here, Browsable is set to no to keep each user's content hidden. The file and directory masks are set to 700, giving only the content's owner total control over it. The %s in the valid users and path settings is a reference to the username accessing the share folder, which gives each user on the server access to a network folder under their username. It's important to remember that anytime you make a change to these settings, you need to run the sudo service smbd restart command in the shell so that Samba loads your updated settings. So let's demonstrate how this works by creating a new user named JT Kirk. And I'm also going to create a group called HomeShare to which I'll add this user just to keep track of permissions a little bit easier. So we have a user now on our Linux system, and Samba gives us another step, which we also have to add JT Kirk to Samba's internal list of users by running the command smb password. And we also need to create a new directory, which will be the folder containing all of JT Kirk's content. And importantly, set the permissions to chmod 700 to allow this user to have solitary visibility and control over it. By the way, we're using 700 instead of 600 because 700 will give this user the executable permission, which is needed for performing directory traversal. If you just do chmod 600, the read and write permissions alone will not be enough to allow this to work. But don't worry about the user being able to execute scripts on the server, because Samba only reads and writes files but does not allow the users to perform the execute functionality. Now let's give this setup a little test. Here I am on my Mac logged in under myself, wkotsan, and as you can see there is a text file that I created on another computer that I can see right here on the network drive. Let's disconnect from the network drive and log in under JT Kirk. By the way, if you're connecting on Windows, the easiest way to do that is by using the start menu run command, // and then the name of the server. So now that we're logged in as JT Kirk can see his own home folder but can't see mine or the other files that I created. Now as you can see from my settings, I've also got a public folder that anyone who has access to the server can read or write to, which is kind of useful for quick sharing of files between people in my own home. But a more interesting feature I came up with was this read-only directory. This shared directory is one that I can write to, making files accessible to other people, but everyone else can only read from this directory and not write to it. That's why the Samba read-only setting is turned off, but if you look at the access permissions in the file system, my username wcodesson has exclusive write control over this directory. So let's log into the read-only directory as JT Kirk and see what happens. In the test directory, Kirk can see the text file there and read its contents, but he can't delete it. So let's try seeing what else we could do from the bash console. Can JT Kirk create a new file? Nope, he can't. So that concludes my tutorial on how to set up a Linux-based network storage for your home network using Samba server. I hope you found this to be useful. If you did, please hit the like button and subscribe to my channel to keep me motivated to make more content like this. See you next time.